Today's session is a little bit of a thought exercise for you. It's something that I'm passionate about and something I think that the time has come. It's important and now's the time to do it. If you look back at systems engineering, at engineering overall, you can see that we spent a long time digitizing things, but not really yet understanding the connections and the intensity between all these applications to get the value out that we really need to get. So we're going to talk about that today. Does this look familiar to anybody? Right? It's a bunch of siloed systems, point-to-point connections. So engineering systems are complicated, right? Anybody disagree with that? No disagreements. What makes it harder? Process, right? So now that we've connected all this stuff together, somebody has to own the integration, somebody has to own the data, someone's accountable for the business rules and the data model, and the process on top of it makes it even more complicated. Change, which happens naturally across organizations, exposes all those fractures that we like to just kind of shuffle away, right? So when the change management event happens, raise your hand if you stress, right? I stress, it's a ton. Like we learned in the keynote this morning, some organizations have thousands of steps that have to be made to affect the change across your organization. So all those gaps in these systems and how this stuff integrates get surfaced when we talk about change. So my question to you guys is, why is this so hard? Why is traceability so difficult? I mean, we've spent a long time trying to solve this problem, right? Why can't we solve it? Just shoot anybody, anything. Good, I couldn't figure one out either. But here's what I think. I think it's because we're moving data around, but we're not understanding the natural relationships between the data that we're moving around. So a lot of companies have an integration play that depends on copying data from here to there and making sure the data stays in sync over time. And that's great. It's the state of the art, but it also creates a lot of risk. Let's talk about how we got here, just so we understand kind of where we're coming from. I mentioned this is an old school problem, right? We've been trying to study this now for 70 years. The Department of Defense after World War II, all the huge programs they had to make sure that our nation was protected and safe, grew into systems engineering technologies at NASA, where they were trying to save astronaut lives. This is not just about making sure products are on shelves anymore. People are involved now. NATO, in some of its initial working documents, came up with standards for managing software requirements. I mean, this is a problem that we as a nation, as a country, as a world, have really been trying to deal with for a long time. This first generation was kind of us as a society identifying there's a problem here, right? The next generation came organizations like IEEE and COSI, ISO, the Software Engineering Institute. Anybody heard of SEI? What do these guys do? Create standards, create frameworks, create processes. They try to get people to change their behavior so that traceability is more effectively understood across organizations. Keep going farther, we get into actual implementations of things. I'm sure you guys have heard of OSLC. PTC's been doing cloud stuff for a long time. The Agile folks got involved at some point. And then, that Agile manifesto, we move fast, we break things. A lot of this is now leading into the AI world that we're in and the product that we have to offer today, which is Nexus. Well, was Nexus. We'll talk more about that. It's now IQNECT. So this is a very long journey. And we've been trying to solve this problem, like I said, for about 70 years. Did you want to take a picture of that? Go for it. Yeah, we've been trying to solve this problem for about 70 years now, which is a whole lifetime. It's a long time. It was supposed to solve all the problems that we're still facing. It hasn't yet. And why? Right? Because we're moving data around, we don't really understand it. Traceability is an afterthought, especially in organizations with heterogeneous system environments. If you have some PTC over here, some Windchill over here, not Windchill, some JAMA over here, some Doors, you have all these different systems and you're pushing data around to try and glue it all together, that's the afterthought. The afterthought is, how do I keep these systems in sync and moving together? So now is the time for us to solve this problem, guys. What if it wasn't hard? What if traceability was just something that was this, like how we do business? What if it was a first-class citizen? Let's talk about what engineering primitives are. Anybody heard of an engineering primitive before? Okay. Here's 3 examples. Requirements, CAD models, test cases. You can break this down into any granularity you want. It essentially represents the building blocks that you use to build and manage your systems, products, services, whatever it is. But these are the primitives. You use this to build something else. They're the tools. But in any vendor that you go out there to talk to, traceability is not one of the things that they're selling. It's not one of the things that is a first-class citizen. It just isn't there. And that, to me, is the problem. What if we added it? What would it look like if traceability was a first-class citizen? Relationships become first-class. And what does a relationship mean? Relationships between data, relationships between systems, we already have that. But they become first-class when we start to look at them as essential elements of the engineering lifecycle at our organizations. This is such a powerful slide. I'm gonna just let it set for a second, okay? Because the actions in the future world and the current world are not really all that different. We're just dealing with systems that do it for us faster. This is the next level of automation for us in systems engineering. It's understanding. If we can provide context for systems to understand traceability, then we can operate on that. It's so the old Michael Porter, whatever the MBA philosopher guy was, if you can't measure it, you can't manage it, right? So we have to be able to measure trace. To understand how these products and systems work, we have to elevate traceability out of being an afterthought, out of being an SFTP job, out of being a Power BI dashboard. We have to make it an engineering primitive. It has to be something that we focus on first. Any disagreements? Okay, cool. So let's see what happens. What happens when we make traceability an engineering primitive and we treat it like a first-class citizen? Everything changes. Let's talk about 3 scenarios, okay? First scenario is change management. Who's ever had to deal with a change? I know somebody here has. You guys raised your hands before. This happens hundreds of times a day across organizations around the world. I can't tell you how much effort is wasted trying to manage change. But let's just walk through what this looks like in a world where traceability is a first-class citizen. First question we generally have to ask is, what is the impact of this change, right? So what do? Depending on who we are, who our organizations are, the investments we've made in systems, we scramble to go pull data out of these engineering systems, these silos, and assemble them. And where do we start to realize? The cron job didn't run, the data's out of date, somebody updated the template but forgot to update the system. There's a lot of problems here, right? So something that should take moments starts to take an eternity. We figure it all out manually. And then when it all comes together, how confident are you that you got the right answer? Are you 100% confident? 50% confident? Bet your job confident? Like, probably not, right? But when traceability is a primitive, then the system doesn't have to guess the relationships. It understands them inherently, because that's the structure that we built. And that's the world we're trying to operate in. What does it mean to understand? It means you don't ask what changed. The system tells you, and it shows you the impact. I'm not saying anything that hasn't been said in the past 70 years. I'm just saying now's the time we can actually do something about it. Like, we actually have the tools and the knowledge and the talent to do it. You can act. If you know what's happening across your systems, you know what the impact of the change is, you can act quickly. Who's being forced to move quicker with the same resources? Everybody. So yeah, becomes manageable. Now we can put SLAs on change that are actually adherable. We can hold ourselves to them. That's huge. Decisions become defensible. Understanding the change in a system when you can't get all the information about the system, it's hard to defend. You're like, well, this is the best effort. This is the best we can do right now. And I don't know who's ever baked a cake before, or you remember the first time you baked a cake, but the first time you did it, it probably took you 20 times longer than it takes you to do it now after having done it for a whole lifetime. Because you understand how you make a cake. You get all the ingredients out first. You use 1 spoon or whatever. You've solved all the problems. Speed followed your understanding. So if we talk about our understanding of our products and systems, what follows when we understand more? We move faster. It's all logical stuff. Let me show you what this could look like. This is IQNECT. This is our product. And this is a listing of source systems and the projects that are related to those systems. So you can see right now we have 4 systems shown: Codebeamer, Jira, Windchill, and Doors. Anybody operating in an environment like this? Yeah, pretty close. So what if I told you that when you started a project or when you installed IQNECT, you could tell IQNECT about all of the elements of your business, of your engineering process. You could tell it about the relationship between requirements and tasks and how the information fits together. and what systems all that information lives in, and establish cardinality and rules that help you enforce truth and trust and accelerate the development of the relationships. This is what the end impact is. This is today. We're running this right now. And what I want you to see here is, here's a customer requirement specification. Same one from the first slide of the introduction. We have articles here, or elements, or entities, whatever you want to call them, from different systems. Here's Codebeamer, here's Jira, here's Windchill. It's all related. I can see it all here without having to go to all the different systems. So if you can imagine being able to see everything in one place and having the system understand the relationships of the data, change moves faster. So let's talk about the second scenario. Understanding the product. Could you actually tell me what you're building? Like, do you really know end to end? Everything that's included? How accurate would you be? Yeah, it's a rhetorical question, honestly, but it's one that we struggle with because of the disparity of where it's all at. And even if you're on all PTC products, integration between PTC products sometimes is difficult. So if you want to understand, you have to piece it together. It's spread across a bunch of different spreadsheets, systems, different owners, et cetera. But what does this world look like if traceability is a primitive? So if we start with traceability, if we establish what the rules are of how we develop products, and we enforce that on top of all these different systems that already exist, what is different for you when that happens? Well, the system understands. The system understands the product. It understands it because of the relationships that you told it have to exist. So if the system understands the product, we see the whole product. So if I have a question about my product, like show me everything I need to know about this product, I can get it from one place because I already told it where everything lives and I told it how to get that data so we can see the whole product. The alignment becomes real. This is really important if you think about different teams and different disciplines inside of your organization. You probably have different owners for parts than you do for requirements, than you do for drawings. And ERP connections, forget about it. Gaps become visible, right? We understand where there's a gap. If our business rules say that every requirement has to have a complete trace that includes all these pieces, if there's a gap there, it immediately becomes visible. You don't have to build spreadsheets or systems independently to do it. The complexity becomes navigable. This is navigable in both a conceptual sense and a physical sense, right? If I can establish a data model that links everything together, then I can navigate it. I can traverse it in whatever system I want. But we also provide really great user interfaces. So let's show you what it looks like. So remember before I told you we had different products, or sorry, different systems that we were connecting to? These are projects. Now, projects rarely live in one system in your organization, right? Like let's say there's a product extension or a new product introduction or anything like that. You probably have 5 to 7 systems that you use for that whole product. It's organized by project. This is a system agnostic way of understanding where your data lives. It's based upon your actual business operations, what you do every day. If you dig into it, you start to see resource shapes. This is OSLC terminology, and we're building on the foundation, the really strong foundation that we've all developed over time. But these resource shapes essentially represent your business objects that are a part of your engineering program. Once the system understands where the data lives and how it should relate to each other, we can start to do something cool with this stuff. Today, right now, we have a product called AI for Codebeamer that's out in the market. You can go install it in your Codebeamer instance right away. It'll start analyzing your requirements and telling you if they're good or not. It'll tell you if you're achieving your quality standards or if you have coverage issues, meaning basic understanding of the relationship between entities. It'll also start to tag things. You can actually build rules that help you identify problem areas real fast. So in a single dashboard, a single pane of glass, you get a visibility of what your product development looks like across everything, across all your systems. Today, this is possible, but it takes a ton of time. It takes a ton of effort. It's very manual. We think we cracked that. This is what happens when you drill down inside of a requirement. And the really cool thing to see here is that we're looking at individual requirements themselves, and we're looking at the quality and the coverage. But the really, really cool thing is you can see all the different systems that requirements can come from. Could be anything. So For us, this is pretty powerful. This starts to solve the problem. But the reason this works is because engineering has now, or traceability has now been elevated up, because we focus on traceability first. It's not an afterthought anymore. This is what it looks like in Windchill. So if you've used IQNECT before, IQNECT exists today just in Codebeamer. IQ for Windchill is our new product coming out in May. We'll talk a little bit more about. But this is what it looks like if you're in Windchill looking at a part. You can see the upstream and downstream elements right in Windchill. And it's live, it's near real time. So that's pretty powerful. That helps us understand our product. If we want to understand what is in our product, this is how we start to get there. Last big chunk, cross-system reality. We acknowledge that these systems exist in your organization. We understand the point-to-point traces exist and the point-to-point integrations exist. And there's probably even some other things that lay on top of this that have tried to do this in your organization. These systems all have different owners, typically. They all come from different vendors. If we're lucky enough to be all on PTC products, that's great. But they could come from different vendors. They have all different data models. Integration is a real pain. This is not going away. We have invested a lot as organizations, as companies, to build this system, to build this capability. People are really good at working in this silo. People are really good at working in this silo, where it breaks down to these red lines. Your systems aren't going away. They have to be there. To get to where we're at today, we connected these systems through API connections, through data flows, through batch processes, but we didn't really actually unify the information that's shared across all those systems. Understanding the context of what that is doesn't exist today. Meaning is lost between systems. Traceability was a primitive, though. I think you understand where I'm going with this. The relationships start to exist across the systems. The relationships have life cycles of their own. They become first-class entities. They have proper attributes and elements, and they're managed. So what happens then? Your system now spans all of your tools. Your silos become irrelevant, because if you're trying to get information about your product, you can go to the dashboard, look at your project, drill down, and then go right to the important product. You can go right to the system that you're in. Consistency, it's very difficult to maintain, right? Especially when you're pushing data back and forth. IQNECT doesn't do that. The future of traceability does not depend upon taking data out of systems. The systems that you are dealing with are best of breed systems. They're great systems. They have their shortcomings, of course, every system does, but we're not trying to take data out of them. What we're trying to do is connect them in an intelligent way. Again, I'm going to show you this just one more time, just to reiterate the importance of this. These shapes exist across different systems. So if you're a product manager, if you're a systems engineer, if you have responsibility from end to end, this is a place you can go to see how everything is connected and to see how everything works based upon your business objects, not based upon the system they came from, not based upon some artificial intent. It's based upon your actual business intent. So really powerful concept here. And again, digging in, you can start to see some of the requirements and some of the details inside of them. Again, when traceability is elevated to an engineering primitive, we get more information. We get metadata about the trace. We start to really understand how long it's been there, when was the last time somebody looked at it, suspicious traces and management of those things. There's a whole world of opportunity there for us. So lots and lots of stuff. Let's talk a little bit more about the future of IQNECT here. We like to say this is the way. You ever see The Mandalorian? Great show, highly recommended. This is the way, right? It's just when you acknowledge that something is the right thing to do, you just come, yep, this is the way, we got to do it. So what is the right way? Well, we're building it. As a matter of fact, we already built it. And this is being released in May. So you can see here in Windchill, we're now connected to 3 different systems. Windchill itself, Jira, and Codebeamer today, making traceability between systems so that I can click on a part and see the downstream traces within Windchill. So if I'm a requirements engineer, I do my work in Codebeamer. If I manage a BOM, I come to Windchill, I do my work. Now I have the context of what's missing. I can start to enforce the rules. And then I can start, without leaving where I'm at, without leaving the system that I'm in, I can start to understand what else needs to be done. And then I can use the tools I already have, email, chat, whatever, to get in touch with other people and get them to do what they need to do. And in the future, we can even automate more of that. But in order to do that, we have to bring traceability up, okay? This is the view from Codebeamer. So if this was Windchill, looking parts downstream, this is Codebeamer looking at requirements, both up and down. So we take what's great about Codebeamer, we add some stuff on top of it. And this is our semantic search. Semantic search is incredibly powerful. If you understand what keyword search is, you type in a word, if the word matches, it brings back the result. Semantic search is, I type in a word, the system understands that word and finds documents or content that relates to the meaning of that word. That's essentially semantic search. Well, now it crosses your systems. So if I'm in Windchill, I can open up semantic search and go, man, I knew we had a requirement for upper control arms. So just go type upper control arms, and now all the different parts or customer requirement specifications that relate to that show up in the interface I'm working in every day. So lots of cool stuff. This is IQNECT 26.2. It's coming out May 13th. So it's in the final stages of testing right now. These slides are 26.3 coming out in August. So this is currently in, you can see a video of this at the booth, by the way. So that was projects. This is inside of a project with basic metadata here, so you can understand, is the project active, public, private, who's the owner, basic metadata stuff. And then the shapes, these are all customizable. You don't have to use our shapes, you use your shapes because you're teaching the system to understand what you do so the system can help you on your behalf. Again, just digging into requirements. From here, you get a glance at the quality, the overall coverage. These are traceability numbers. This is your compliance internally. Does this requirement meet our internal standards, yes or no? We can sort and filter. We can make sure that traceability between this and the downstream parts or whatever they may be is maintained. The system manages all that for us only because we've elevated traceability up. We've made traceability a first-class citizen. That's coming out in August. So, the future. Relationships are defined. The system enforces them. We now can use that data. Very simple. Now, we haven't talked much about AI. Lots of companies talk about AI. AI is really important, but for us, it's not the headline. It was the headline, it's not anymore. But in order to get to where AI needs to be, we need to put in more context. We need to put in more understanding. Because if you've worked with AI in your day jobs now, it leaves a little to be desired. And the chat interface is great, but there's better ways to do this. Giving the AI the context of what your systems engineering process looks like in a structured way opens up a lot of value. A lot of value. We've got use cases I'm not even talking about yet that are fundamentally going to change the way you do engineering. And I think this is the key that's going to unlock it for us. You'll be able to get analysis, insight, assistance in the flow of the work you're doing every day. We don't want to take you out of your PTC tools. We don't want to take your data out of the tools. We want to help you in the tools that you're in. Also, fundamentally, IQNECT as a company believes in people. We like to think that we always are customer driven. Our customers like working with us. Everyone tells us that. No one ever tells you you're ugly, right? But from a philosophical perspective, our goal for AI is not to replace people. Our goal for AI is to enable people so they go home early, so they get more done, so they're focused on higher order value creation. That's really what this is. Because if you think about the gaps between the systems, they're held together with glue and duct tape and hope. So if we get people avoiding that work, what else could they start to focus on? What else could we focus on if we had AI that really did work, that helped? That's important. So we talked about 3 different use cases: change, product understanding, and that our systems aren't going anywhere. Just want to reiterate, there's an infinite loop or infinitely more of these that you'll see benefit from. But it all comes from the act of elevating traceability out. That's the mantra today. It's not really about IQNECT as much as I want it to be. But I think what it is that we've been doing this for so long, we now understand the problem. The problem is traceability. I think we've actually nailed it. I think we solved it. We've already digitized everything. When was the last time you pushed paper around? Probably have been a real long time. But now we've unified understanding. Let that sink for a second. We've unified understanding. The context, the understanding of the process is what helps link all this stuff together effectively. We've unified it in IQNECT. Traceability is an engineering primitive. This is unified engineering. This is digital transformation. And this is IQNECT. So thank you all for your time. Happy to answer any questions you have.